Hi, I'm Alain Suarez, and this is the intro video for the Augmented Reality Collaborative Game project, version 0. Our project is an application that seeks to use the Microsoft Hololens platform to its full potential. Microsoft Hololens is a headset unit that allows you to view and interact with holograms in a real-world space, while also having all the capabilities of a desktop computer. The HoloLens platform has features such as spatial mapping, hologram rendering, voice recognition, and gesture recognition. Our project is a simple game reminiscent of the ball and maze games geared towards children, but with a collaborative and challenging twist. Users take turns attempting to move a ball to a goal within a time limit, with the added twist that the person allowed to control the ball does not have it rendered in their view. We believe that our project will serve as a template for other HoloLens applications seeking to incorporate collaboration, whether their purpose is recreational or educational. For project management, we use the Agile methodology. We use Google Docs and Mingle for collaboration and documentation. As can be seen from this Gantt chart, we have some unimplemented features. This is due to technical difficulties. Over the course of the semester, Chitin and I were able to implement 8 user stories. Play Game concerns itself with the main gameplay cycle. Implementing it involved creating a game controller, which is essentially the heart of the application. Interact Maze is the user story that concerns itself with manipulating the maze and sharing that manipulation between the HoloLens headsets. Begin Game is the user story that sets up the initial state of the game and shares coordinates between the headsets so that they may synchronize. View Game Info is the user story where we create a UI that gives the user feedback on their gameplay. End Game is the user story that allows the player to complete the game. It also synchronizes the goal state between the headsets and prepares the game to either be terminated or reset. Reset Game is the user story where the game is reset to a previous state so the user may play again. This occurs on both headsets. Difficulty Menu for Maze is the user story where we add various difficulties of play and the ability to pick between them. This adds variety to the game. UI for Maze is the user story that focuses on making the UI for the application more appealing. Here is the use case diagram for the entire project. For the system design, we use the model view controller architecture and the client-server architecture. Game controller was our main controller, as per Unity design guidelines. To deploy the project, it requires 2 HoloLens headsets and a Windows 10 PC. The Windows 10 PC and the headsets must be connected to the same local network, and the PC will be used as a server for the clients. A special HoloLens Unity build and Visual Studio 15 are required to deploy to the headsets. The minimal class diagram shows Game Controller as the main controller for the application, Puzzle as the main model, and Text Edit as the main view. To test on Unity, we designed test cases that would print out debug messages and designed a cursor light that would give us visual feedback on the state of the game. This is one of our sunny day test cases. It's part of Play Game user story. The purpose of this test case is to test that hologram placement will correctly allow the user to position the maze where they want at a gesture tap. So to test it, the user looks around and does a gesture tap where they wish to place the maze. The expected result is that the UI will update and the maze will lock, and this was the actual result. This test case is one of our rainy day test cases for Play Game user story. Its purpose is to test that the hologram placement script will now allow the user to position the maze at a gesture tap if they're not looking at it. To test it, the user looks in a random direction and does an air tap gesture, making sure that they're not looking at the maze. The expected result is that the maze will lock and the UI will update, but it does not. Since most features would not work on the emulator or the Unity editor, I'll show footage of an actual deployment of the application. First, the user is able to choose with gaze and air taps the difficulty in the menu options. Then, by looking around and walking around the room, they may place the maze where they choose using an air gesture tap. The game has chosen Chitin, whose view we're watching, to be the second player. So I enter the rectangle. While the maze is invisible to me, Chitin directs me as to which way I can go to guide the ball towards the goal. On Chitin's turn, it can be seen that the maze goes invisible, and then he gains control of it. Note that he is still able to see the rectangle that allows him to manipulate the maze. And when his turn is over, the maze becomes visible to him again, but he loses control over it. In a later playthrough of the application, Chitin and I were able to successfully complete a simpler version of the maze. The next video's focus will be a user guide for the application. Thanks for watching.